फरवरी मार्च 2020 का वेरिएंट S2 का हम लोग स्टार्ट करते हैं। पहला क्वेश्चन, आराम से इसको पढ़ें। Booklets produced by a certain publisher contains on average one incorrect letter per 30,000 letters. ये एक वैल्यू दी हुई है 1 out of 30,000 and these errors occur randomly. A randomly chosen booklet from this publisher contains this many letters. Use a suitable approximation or a suitable approximating distribution. Find the probability that this booklet contains at least 2 errors. Now, if we look at this question, what exactly is this question about? So we would say originally it's about binomial distribution. We are talking about 12,500 letters and the probability of success is probability of making an error that is 1 over 30,000. So this is the original distribution, but we have to use a suitable approximation. So what is the suitable approximation? Always calculate expectation of x, that is NP, that is 12,500 into 1 over 30,000, which after using a calculator comes out to be 5 over 12. This is the fraction that you get. Or if you want to write in decimals, you can also write in decimals. Now you would justify this approximation. You would say since n is greater than or equal to 50, at the same time, simultaneously, NP is lesser than 5. Therefore, x now follows a Poisson distribution with 5 over 12. So that's how you do the conversion. And what is the range of values for which you have to do the calculation? That is at least 2. So probability x is greater than 2. What is the next integer? That is probability x is greater than or equal to 3, which is 3 all the way to infinity. So there is no harm in drawing a small number line. This is 0, this is 1, this is 2, this is 3, and so on. So probability x is greater than or equal to 3. That is 1 minus probability of 0, 1, 2. So 1 minus probability of x is less than or equal to 2, which is 1 minus e raised to power of minus lambda, 1 plus lambda square over 2 factorial. You would be using a calculator and then you will get your desired answer. So question number 1 for 3 marks. This is about Poisson approximation to binomial. So this originally was a question of binomial, but because of approximation, this is Poisson approximation to binomial. Both distributions are discrete, so there is no continuity correction. So that's the first question. Let's move to the second one. Now let me label this question and then now I'll start reading it. The question says, lengths of a certain species of lizard are known to be normally distributed with standard deviation 3.2. Normal the mean is not given yet. A naturalist measures the length of a random sample of 100, obtains an alpha % confidence interval for the population mean. So let me label it. This question is about confidence interval for population mean, and then it would either be asking about calculation of this confidence interval or the width. Let's see. He finds that the total width of this interval is 1.25 centimeter. Find the percentage of confidence interval, which is denoted by the symbol alpha. So now the formula for width is 2z sigma over root n. You don't need the x bar. So width is 1.25 and 2 as it is, z is unknown, that will determine the percentage. Sigma is 3.2 divided by square root of n, that is square root of 100. If you comfortably make z the subject, and let me grab my calculator, let me do some calculation. So 1.25 multiplied by 10 divided by 2 multiplied by 3.2. I'm first writing it down, then comfortably doing the calculation. This z value comes out to be 1.953. Now don't jump into conclusion. Of course, you have to use the z table, that is for sure. So go to the z table, erase any marks before. 1.953. So this is 1.9, somewhere here is 1.9, and then 5, keep on going straight till you reach the 5 value, which is 9744, and then 3, that is 1, 2 and 3, so that is the value. So that is 9, 7, 4 and 6. So therefore the probability that you get is 0.9746. But this is not what is required, because this distribution is symmetric. So when it's symmetric, draw a normal distribution curve like this on one corner and label this value as 1.953. So this is 1.953. This is negative 1.953. This probability left of 1.953 z value is 0.9746. Therefore, right of 1.953 would be 1 minus this value. So 1 minus this value, 1 minus 0.9746, 9746 comes out to be 0.0254. This is the value that you receive. Now on this right, extreme right, this is 0.0254 or 2.54%. Similarly on the extreme left is 2.54%. So therefore this middle one is that alpha percent confidence interval. So therefore this percentage plus 2.54 plus 2.54, everything is in percent, should equal to 100%. So therefore this comes out to be 94.92%. That is the value of alpha percent. If you want to round it up, which as such you should not, because this you should round it off to 3 significant figures. Of course you should round it off. What I wanted to say was that don't round it off to an integer. So this is 94.9%. Usually the kind of confidence interval that we calculate is 95%. So that is the answer for this particular part, confidence interval for population mean. Let's move to the third question. Let's read this question and let's see what it's all about. It says, in the past, the mean time taken by Freda was for a particular daily journey was 39.2 minutes. So this is the mean time taken, was 39.2 for the daily journey. Following the introduction of a one-way system, Freda wishes to test whether the mean time for the journey has decreased. So it feels like it's a question of something like a hypothesis test or something like some unknown mean and standard deviation unbiased estimate. She notes the time for 40 randomly chosen journeys and summarizes the results as follows. So this is the result as follows. First of all, what is it asking? the very first thing that they are asking is unbiased estimate of population mean, unbiased estimate of population variance. That's the first part. Then it says test at the 5% significance level whether the population mean time has decreased for another 5 mark. So altogether it's an 8 mark question. First and foremost, unbiased estimate of population mean, I'm using this symbol. Unbiased estimate of population variance, I'm using this symbol. For unbiased estimate of population mean is the same thing as sample mean, that is sigma x. Actually this is t in this scenario, so let me use the proper symbol, which is t in this case. So this is t bar, which is sigma t divided by n, which is 1504 divided by 40, and this value comes out to be 37.6. That is the average time. Unbiased estimate of population variance, it's n over n minus 1 sample variance. This is the formula I personally like to use. Of course, in the formula booklet there is a direct formula, people use that, but I'm just addicted to this formula. So therefore S square, the sample variance, that is sigma t square over n minus t bar square, that is 57760 divided by 40 minus 37.6 square. You will get the value for S square. Then you plug in this particular value, this value over here, whatever you obtain in this place, and that is S square. So that is 40 over 39 into this value, and that will give you the final answer, which comes out to be 31.0154, 31.0154, and round it off, that is 31.0, correct to 3 significant figures. Now if you have to use it for the next part, if there is a need, if needed, so then we will be using the unrounded value. That is the answer for this part. Now what does the question further says? The question further says that test at the 5% significance level whether the population mean time has decreased. So now there are some subheadings that I personally like to draw. First of all, I will describe what is the distribution all about. Secondly, I'll write down the alternative, the null and the alternative hypothesis. Last but not the least, I'll calculate the value of z. And actually the very last thing, that is about application of the normal distribution curve and then deciding upon the answer. So first of all, I'll write this as normal distribution. That's the first thing. So therefore x bar follows a normal distribution. The mean that is happening in the past, that is 39.2. And since variance is not given, we would use unbiased estimate. That is 31.0154 divided by 40. That goes over here. And then was there any sample value? Of course there was. We would use unbiased estimate of sample mean, which is the same thing as x bar. That is 37.6. Second thing, the hypothesis, the null hypothesis and the alternative hypothesis. H naught, that is the status quo, things as it is, that is 39.2. H1, it's about decrease, it's a one tail test, it's a lower tail test, it's for 5% significance level. So let me go to the table, let me label this thing as 5% percentage. So this is 5% and this z value is negative 1.645. That is the standard value, and of course you can look it up in the strip over here. For 95% it is 1.645. That is the first thing. Now what else is there? Calculation of z. Z is x bar minus mu. So this is a sample mean calculation divided by sigma square over n under root. So x bar is 37.6 minus 39.2 divided by 31.0154 divided by 40 square root. And let me grab my calculator. Let me plug in some numbers, and if I do this to the calculation, this comes out to be negative 1.817. This is the calculated z value. Now this calculated z value, it lies inside the critical region. Z calculated value lies inside critical region or rejection region. What is the conclusion? Reject H0. Further you can write accept H1. What is H1? That the mean has decreased. Whether the population mean has decreased, yes, you would say there is sufficient evidence to suggest that the mean has decreased. The mean journey time has decreased. So that is how you solve a hypothesis question. And this one was hypothesis. And this hypothesis was related with normal distribution. Of course, there should be a question related to type 1, type 2 error. So now this thing is done. Let me move to the next question. That is question number 4. The number of accidents on a certain road has a Poisson distribution. So now let me do the labeling. This question is about Poisson distribution. And what exactly in Poisson distribution? Basic calculation, some more calculation. So basically this is just Poisson distribution. It says the mean is, let me underline this, the mean is 0.4 per 50-day period. So now there will be probability, there will be fewer than 3 during a year, that is 365 days. So let me write this down. There is days and there is number of accidents. In 50 days, you have 0.4 accidents. Therefore, in 365 days, you have lambda accidents. So lambda is basically the number of accidents. So let me do some ratio proportion. 50 lambda, that is equals to 0.4 into 365. Therefore, 0.4 into 365 divided by 50. This, wait a minute, 0.4 into 365 divided by 50. This comes out to be exact 2.92. So now you would say X follows a Poisson distribution with 2.92. That is the number of accidents. Now, what is the definition of Poisson distribution? We have something called mean number of occurrences in a specified time or space interval. So when we talk about this, so this thing that we are talking, that is the mean number. So the number of accidents in a particular time period. So therefore this number of accident is your mean. It's your lambda. It says here too. So 2.92, now it says lesser than 3. Probability X is lesser than 3. Lesser than 3 does not include 3. So less than or equal to 2, which is e raised to power of minus lambda. 1 plus lambda square over 2 factorial. Of course, you would use a calculator and then you will get your answer. So that's how the first part is done. Now let's move to the second part. When we move to the second part, what does it say? The probability that there will be no accidents. So let's underline this. The probability that there will be no accidents during a period of n days, no accidents during a period of n days is greater than 0.95, that's the probability. First of all, let me write this thing. Probability x is equals to 0, that is simply e raised to power of minus lambda. Now, there is an unknown lambda. We don't know what lambda is. So, this probability is greater than 0.95. First of all, take log, natural log of both sides. When I take natural log of both sides, ln e raised to power of minus lambda is greater than ln of 0.95. Minus lambda ln e is greater than ln of 0.95. ln of e becomes 1. Minus lambda remains as it is greater than some negative value. This negative value is 0.051293. 0.051293. Now what will happen? Since the coefficient of the variable, this is important, the coefficient of variable is negative, irrespective of the other side is negative or not, the inequality flips. So therefore, what do you get? You get like this. So therefore, lambda is lesser than 0.051293. This is what you get. Now, your calculation would be based upon this. So lambda, this is the greatest value, correct? So now again apply the concept days and the number of accidents. What is the ratio? 50 is to 0.4. 50 and 0.4. This time you got the value of lambda and you want to calculate the number of days. So therefore, this is 0.051293 and this number of days is n. That's the symbol that they have used. Apply the concept of ratio proportion. Therefore, n into 0.4, that is 50 multiplied with 0.051293. So when we do the calculation, again the calculator, so 50 multiplied by 0.051293 divided by 0.4, this comes out to be 6.411 days. Now remember, the inequality is this thing, and they are talking about number of days and the largest possible number. So what should I do? Draw a number line and like this, and label the values. Something like this is 0 and this is 1 and so on, and this is 5 and this is 6 and this is 7 and this is 6.411, and you are going in this direction because of this inequality, because the inequality is exactly the same. That's the largest, this is the largest. So what is the first integer that comes in your way? The first integer that comes in your way is 6. Therefore, the largest possible value of n is 6. So it's a beautiful question related to Poisson distribution, related to basic concept of ratio proportion. Let us move to the next one. Now this is of course obvious. What is this question about? Naturally, this question is about CRV, that's continuous random variable. Now it says bottles of a drink contains 300 ml of juice. So let me first underline things. These bottles contain 300 ml of juice. The volume in a bottle is 300 plus x. That means they are talking about excess. That's the main thing. 300 is what is the standard. Something more than 300, that is x. What is x? Where x is a random variable with a PDF given by such and such. So now what exactly are they trying to tell us? They are trying to tell us that the bottle will be having 300 ml of juice. It could be plus 10 ml. It could be negative 10 ml. So it would lie between 290 and 310 ml. This x would be the excess. Now the function is a quadratic function. So let me read all the parts, because I have a hunch that it would be something related to symmetry also, because that's the examiner's favorite part. First of all, it says find the probability randomly chosen bottle of Lanta contains more than 305. That is the first part. Given that 25% now probability is given, contain more than this many juice, show that this cubic equation is there. Third part, given that P is something 3.47, 50% of bottles contain between this and this is 50%. Find Q for 2 marks, justify your answer, something related to symmetry inshallah would be there. So now the first thing, the first part, more than 305. So basically 300 plus x is 305, therefore x is 5. And it's talking about more than. So probability x greater than 5. That means your lower limit is 5, your upper limit is 10, your function is 100 minus x square dx. Don't forget the constant 3 over 4000. Therefore, this is 3 over 4000. When you integrate it, that becomes 100x. This becomes x square over 2. Of course, you should know your basic P1 integration as well as P3 integration. And then you plug in the lower limit 5, you plug in the upper limit 10, and this I leave it for you because that's too obvious to be displayed. Of course, everyone is well aware of this calculation. Plug in the upper limit, plug in the lower limit. Let me just do this much because you never know what is the understanding level of integration for some people. So it's a good idea, so just go through it. So that's 100 into 10 minus 10 square over 2. Then the lower limit 100 into 5 minus 5 square over 2. Naturally use a calculator and then you get your answer. So this is the first part. Now let's move to the second part. Now the second part is all about 25% contain more than 300 plus P. So this time the value of x is P. Probability x greater than P is equal to 0.25. Now you have already done some calculation. So this is P, this is 10, this is 3 over 4000. This is 100 minus x square. This is dx equals to 0.25. Have I written a dx at the top? Yes, I have. So that's 3 over 4000. And this is 100x minus x cube over 3. Was it x or x square? This was x square, so a small mistake over here. That is something like this, something like this. So therefore this is x cube over 3, 10 cube over 3, 5 cube over 3. So that's how it is. So now in this scenario, your lower limit is P, your upper limit is 10, that is 0.25. First of all, let me multiply 0.25 into 4000 and then divided by 3. Should I divide by 3? No use. Leave it as it is. Let it remain as 1000. Let it remain as 3. This is 100 into 10 minus 10 cube over 3. This is the first thing. Let me push this to the side. And then this is P, 100p minus P cube over 3. And then this is equal to 1000. So that is something like this. And of course you would multiply by 3 and then simplify and all these things. So therefore this is 3000. This is simply 10 cube. This is again multiplying by this thing. So therefore that is 300p minus p cube. Okay, I'm keeping the bracket intact. That is equals to 1000, and then inshallah you would be getting this particular answer. So that was the second part. Now it says given that P is equals to 3.47. Now this part is related to part B, that the probability x greater than P is 25%. Okay, got the idea? P is equal to 3.47. 50% of the bottle contain between 300 minus Q and 300 plus Q. So again, normal distribution curve to the rescue. Now, what exactly is it trying to tell us? It's trying to tell us this is 300. Somewhere here, is 300 plus q. Somewhere here is 300 minus q. And in between these two lies 50% of the distribution. So therefore, in between these two values is 50% of the distribution. If you know your S1 very, very well, you would have realized that this 50% in the middle, in other words, this thing is your upper quartile, this thing is your lower quartile, because this is 50% and at the corners there is 25%, at this corner there is 25%. Now, isn't this equation probability x greater than something is 25%? So that something would be this q, because we are talking about the x's. And isn't this the same thing as the previous part? So what is q? Q is in fact p, that comes out to be 3.47. The extra 1 mark, that is basically for making this particular diagram. Understand it once more. I'm going over it. The previous question was 25% contain more than 300 plus p. And isn't this 25% more than 300 plus q is 25%? Yes. And 300 minus q and less, this is more, this is less, that is also 25%, because the middle one is 50%. That says over here. So therefore this q is nothing but p, and the value of p is 3.47. As such, there is no calculation involved. It's pure brain work. Okay? So it's pure brain work. It's pure understanding the concept of symmetry, and that's how this thing is applicable. Now, I have applied the concept of normal distribution. As such, this was not normal distribution. So what I can do is that I can draw a quadratic curve, because this is the function is 3 over 4000, and this is 100 minus x square, which is 3 over 4000. That is 10 minus x, and this is 10 plus x. The basic concept is still the same. So if I draw this diagram, that's the x-axis, that's the y-axis, and that is the normal distribution curve, something like this. So now if I want to limit this thing, and let me use a eraser so that I can keep this intact, and this is like, this one is basically negative 10, this one is basically positive 10. The same concept is applicable, and somewhere here is your value, that is q, and this thing is, my bad, this is q, and this thing is negative q, and in between the two is how much of the distribution. So in between the two, that is this one is 50% of the distribution. So the same concept which I explained by using a normal distribution curve, I am using this curve. So now this is 50% of the distribution. This corner is 25% of the distribution. This corner is 25% of the distribution. So greater than q is 25%. Therefore q is the same thing as p. So this thing is done. Now let's move to the next question. Read this question again. What is it about? The volume in milliliters of a large and small cup of tea. So you got it right. This question is about linear combination of random variable. In this scenario, that variable is normal distribution. So now it says the volume is such and such, and then it says large, L for large, and S for small. Large follows a normal distribution, 200, 30. Small follows a normal distribution, 110, 20. Find the probability that the total volume of a randomly chosen large cup of tea and a randomly chosen small cup of tea is less than 300 ml. So let X be equals to a large and a small cup. So X follows a normal distribution, the means are added, the variances are added. Remember, the rule is about variance. So probability X is less than 300, probability Z is lesser than 300 minus 310 divided by square root of 50, and then knowledge of S1 normal distribution is assumed and you know how to do the working. Next question. Find the probability that the volume of a randomly chosen large cup is more than twice. Now the word twice is there. Twice the volume of a randomly chosen small cup of tea. So let me write down this data. Let me just copy it. And this comes over here. I don't know, there's some problem with this copying thing. L follows a normal distribution. So that is 200, 30, and I think S follows a normal distribution, 110, 20. Is that so? Yeah. So now it says large is more than twice small cup. So 2S follows a normal distribution. That's 2 times 110 and 2 squared times 20. So first of all, focus on this one. That's 220 and 4 times 20 is 80. Large contains more than twice small cup. L minus 2S is greater than 0. Let W equals to L minus 2S. W follows a normal distribution. The means are subtracted. So this is 200. This is 220. So 200 minus 220, that comes out to be negative 20. And the variances are always added. So this is 30, this is 80, this comes out to be 110. So probability W is greater than 0 based upon this thing. Probability Z is greater than 0 minus negative 20 divided by square root of 110, and you are back to the basics of S1. So that's how the straightforward question of linear combination is done. Now in this paper, there is one question, and of course which is the last one, that is slightly tricky. Now in this question, we have to think a little bit outside of the box. So let's first read the question. The question says, a national survey shows that 95% of year 12 students use social media. Arvind suspects, the question is always based upon a suspicion, that the percentage of 12 year students at his year 12 student at his college is less than the national percentage. That's the national thing, and it's lesser. He chooses a random sample of 20 students, notes the number who use social media. He then carries out a test at the 2% significance level. Find the rejection region of the test. And then it says, find the probability of type 1 error. And Jimmy believes, and this is type 2, and so on. So first of all, let me label the question. This is about type 1 and type 2, and naturally rejection region, and the distribution is binomial probability distribution. And this is for 4 and 1 is 5, 5 and 3 is 8 marks, but one part would be a bit tricky. Now we know that we have to use trial and error to find the rejection region. Now first of all, X follows a binomial distribution n comma p. Probability X is equals to R, that is NCR. Success raised to power of R, failure raised to power of n minus R. This is a lower tail test. So H naught, probability of success is 95%, which is too high. So that's the first thing. Usually the percentage is like 10, 12, 20, 30%, but this is 95%. So something mischievous is there. Probability of alternative hypothesis is lesser than this thing, and we are using 2% significance level. Now, in order to find the critical region, I should start from the very, very small value. And that small value is, for example, probability x is equals to 0. So when I calculate this probability, that is NCR, that is 20, x follows a binomial distribution 20, 0.95. So now this is the thing that I'm starting with, that's the binomial distribution. And I'm starting with the first value. Probability x is equals to 0, 20 C0. Success raised to power of 0, failure raised to power of 20, which you can definitely say the answer will be very, very small. So let me go to the calculator. 0.05 raised to power of 20. Guess how small is the answer? That is 9.54 into 10 raised to power of minus 27. That is 9.54 into 10 raised to power of minus 25%. That's too small. If I calculate the other value, probability x is equals to 1, that is more or less in this range. That means what needs to be done? What needs to be done is that these values would be too low. So let me start from the other side and do some subtraction. So if I start with, for example, probability x is equals to 20. So if I start with probability x is equals to 20, that is 20 C20. Success raised to power of 20, failure raised to power of 0. This answer comes out to be 35.84%. I have done these calculations and kept it on the side because this question was truly out of the box. Now this is a big value. It makes some sense now. If I calculate probability x is equals to 19, this comes out to be 37.73%. That means the bulk lies on the higher side. Probability x is equals to 18, that is 18.87%. I'll just get all things together. Have some patience. Probability x is equals to 17, that is 5.96%, and probability x is equals to 16, that is 1.33%. That means my critical region would be something like this. Probability x is less than or equal to 19. That means the probabilities are so high that I have to think like that. It's a lower tail test naturally. So critical region would be in this direction. So this is 1 minus probability x is equal to 20. Yeah, in percentage or in decimals. So that comes out to be, again, let me grab the calculator. So this is 100 minus 35.84. This comes out to be 64.16%. Too high. We have to get it to the level of 2%. It should get below this. That's the rule. Let me go to the next part. Probability x is less than or equal to 18, which is 1 minus probability x is equals to 19, and probability x is equals to 20, and we have to do it with patience. So therefore this is 1 minus the percentages. So therefore 100 minus 35.84 minus 37.73, this comes out to be 26.43%. So this one is basically 100%. Let me move to the next one. X is less than or equal to 17. 1 minus probability x is equals to 19 plus probability x is equals to actually 18. You start with 18 first. So that is 18 plus probability x is equals to 19 plus probability x is equals to 20. So therefore again subtract, add these three. That is 35.84 plus 37.73 plus 18.87, and then subtract it from 100. That comes out to be 7.56%. That means a little bit more is left. Probability x is less than or equal to 16, which is 1 minus probability x is equals to 17 plus probability x is equals to 18 plus probability x is equals to 19 plus probability x is equals to 20. Of course, I can write it as greater than or equal to 70. So let me subtract one more probability. So that comes out to be 7.56 and this is 5.96. 5.96. This comes out to be 1.6%. So now I think I have hit the jackpot, because now the probability is lesser than 2%. Now think closely for a second. Okay, what is the critical region? The critical region should be all those values which will make the probability lesser than 2%. So therefore the critical region, the rejection region, that is x is lesser than or equal to 16, a very high value which can only be done by doing the subtraction. If you were keep on adding these small values, it would take a lot of time. That is why by looking at this and then this calculation that was also more or less of the same caliber, I moved to the other part and start doing the subtraction. Got the idea? So this was truly an out of box question. So this is the value of this thing, and then it says what is the probability of type 1 error. So probability of type 1 error is actually the true significance level, and that is probability x is less than or equal to 16. So if my calculation is all correct, so this should be 1.6%. that is the probability of type 1 error. Now it says Jimmy believes that the true percentage of at Arvind's college is 70%. Find the probability of type 2 error. So probability of type 2, given that the true probability of success is 70%, that is simply flipping the rejection region. So that is greater than or equal to 17. So that is 4 calculations. So let me write it. That is 17 and then 18 and then 19 and then 20. You have to do the calculation for all these 4. So therefore probability x is equals to 17, 20c 17. I'm just setting up the format. 20c 18, 20c 19 and 20c 20, but now the probability of success is 70%. So therefore this is 70% all over here. This is 70%, this is 70%, and this is 17 and 18 and 19 and 20. Failure is 30%, 30%, 30%, 30%. So this is 3, 2, 1, 0. You do all the calculation. You calculate this, you calculate this, you calculate this, you calculate this, and then you add it all up. That is the probability of type 2 error. So that the second part was not difficult. The third part was not difficult. The main difficulty was because of the fact there was such a high percentage of success that even though we had to go towards the lower tail, we had to do it by subtraction. So this was truly an out of box question. So that completes this particular paper. That is Feb March 2020 S2 paper, which is paper number 6. I hope this you will find this paper useful, and inshallah we would be doing more papers like this in the same sequence: June 2020 and then November 2020 and then 2021 and so on. Take care.